Hi guys, in this video we are going to learn about the serverless concept, right? And each and every public cloud is supporting for a serverless computing and the serverless architecture, right? Either it is Azure, maybe it is a AWS, maybe it is a GCP, right? And what is the difference between the serverless, especially AWS Lambda versus the microservices? So let's go a little deep inside in it. So here we are discussing about the concept of a serverless architecture, also AWS Lambda and the microservice architecture. So I can tell you one thing, you can also develop the microservices using the AWS Lambda, correct? But before that, we need to understand what is the serverless architecture, correct? Any point of time, if you wanted to run any server or any computing task, right, you need a hardware. On that hardware machine, you need to have a softwares, correct? So whenever you are having a softwares, maybe it is developed into a React.js or maybe Node.js, Python, or any other language, .NET, Java. Maybe it is processing heavy data, streaming data. It is a gaming app. Maybe it is a simple REST API where you are sending data from your UI layer, React.js and Angular, and you are processing at the back end. You are generating some result, right? Or you are processing some data, you are sending to any other message queue, or you are taking up some of that event based on some certain conditions, right? So after the event you want to perform some task, right? Like this there can be a different combinations and different kind of a task, right? So in these places you can also use a AWS Lambda. So when we are talking about, you need a hardware, you need a software to run on it, right? So that your application will be up and running and you can start processing it in place, right? You can definitely provision your hardware on any particular cloud whenever you are creating an elastic cloud compute or EC2 on your AWS, right? You can still set up your all softwares. You can deploy the softwares using Docker or maybe without any Docker also. Either it is a C sharp application, Python application, Java application. If you are, let's say you are setting up that Java applications. So in that scenario, what is happening here? Uh, you will need to deploy all these application, but before that you need to create a runtime. So you need to install JDK, Maven, and all these details. If you are running through Docker, you need to install the Docker, and then you will be able to run it. But in case of serverless, right, you don't need to work on these processes here. Serverless is a cloud computing model where the cloud provider manage the infrastructure, nothing but your entire your operating system, your hardware and everything. So it is allowing developer to focus on directly on code deployment. So you just need to upload your script files or maybe jar or maybe your binaries, right? And your application will be up and running without installing and doing all this setup here. That is the something we can call as a serverless. So characteristic of a serverless architecture, serverless architecture is event driven, highly scalable. So you can also create event, as I told you, right, based on some event. So let's say you are putting some message in your queue, and queue based on that you wanted to trigger something, right? So that task you wanted to perform, that can also be, you can do it through a Lambda, correct? Let's say on any particular situation you wanted to perform some task, right? It is not coming through a, what we can call as through a message from the queue. There can be some other events also, right? Based on that also you wanted to perform some task, and you can also expose your APIs, something we can call as a REST APIs also, right? So it is highly scalable, required a no server management. So you don't need to manage any servers, right? Especially your upgrade patches, right? Managing that entire, you can say, machine. So you don't need to do all this. And you can also use auto scaling, right? So using the auto scaling also you can scale any point of time. You can connect this AWS Lambda with the API gateway. So AWS API gateway can be connected to AWS Lambda, right? That can also be very much possible. So an API gateway can connect to multiple other microservices also. So depends on your understanding and depends your requirement and microservice architecture. You can also create one of the microservices as a serverless architecture on AWS Lambda also. And AWS API gateway can connect to multiple other microservices also, right? There is a lot of other serverless services. AWS Forget is there, AWS AppSync is there, correct? And many other services also there, which is coming over as a AWS or serverless, right? You don't need to manage any kind of infrastructure. Even there is some database which is AWS provide, right? Amazon Athena and DocumentDB or so DynamoDB is especially we can say. These are also some of the services which is serverless, which you don't need to manage anything. Everything is managed by the AWS itself. So challenges, serverless involves debugging difficulties, right? So when some problem is going on, when you are processing something using the AWS Lambda, right? So in that scenario, there is a difficulties to check the logs and see, so to pinpoint exactly where this problem is coming up, correct? There is also latency issues, right? And limit on execution duration and the resource uses. So there is also a limit for execution duration also, correct? So these are some of the challenges. If you use your own microservices, which is correct. So these are some of the challenges. If you use your own microservices, which is built on top of your own API, right? Maybe it is Java or maybe it is Python, maybe it is Node.js and some other APIs. In that scenario, right? These issues will not be directly coming up. Maybe it depends on the location, our infrastructure, and what we can say, um, particularly the system on which you have deployed these. So these issues will have a different other parameters, but these can be potential issues. You can face it on AWS Lambda. Advantages, it is completely serverless, include your reduced operational complexity, cost efficiency, automatic scaling, and faster time to market for an application. So you don't need to completely put an effort for deployment, you or maybe setting up everything on particularly a cloud here, right? So all these things is already taken care by the cloud provider. Maybe it is an AWS or Azure, or on Azure you can use as a app function, correct? So AWS Lambda, here there is a concept is a function as a service. So I already told you, right? This particular AWS Lambda, you can also expose some of the endpoints and can also take your request, generate the response, right? It can perform multiple high computing tasks as well, right? So function as a service is a cloud computing service that allows developer to run individual functions without managing servers. Don't need to manage any particular servers, and you can run a multiple functions which is can perform a different task, right? And it can easily scale also. That point we already discussed. Event driven execution, it can be triggered. You can trigger that AWS Lambda based on some certain events when you receive any message, right? Live streaming data you wanted to process, or there can be different other triggers you can make it, right? Or in response to specific events also, right? So it simplifies application workflows. So when you wanted to process anything, right, after generating an event, it can be generated from your own system also, it can be generated from AWS broker or SNS and SQS also, or there could be some other events also. So the workflow will be a very seamless and it is easily integrated. Now, common use cases for AWS Lambda, real-time processing, right? Streaming, I told you, right? Maybe high computing tasks, data transformations, right? Data engineering, warehousing applications, you can use it, right? Backend services and event generations, if you wanted to process and any task based on some events, right? Data event-driven applications, right? Generally, we use a Saga and asynchronous communication. So these kind of a process, you can also use it AWS Lambda, right? So it is ideal for scenario requiring a dynamic scaling and minimal infrastructure management here. Correct. Best practices, AWS Lambda includes optimizing function performance by keeping code concise here, right? And you can managing the resource limit. Another thing is it is pay per use, right? How much you are using, receiving a request. So the cost will be accumulated based on that pay per use, right? So this is you need to understand. It can be monitored using the CloudWatch and Cloud Alarm, right? And these strategies ensure that efficient and cost-effective use of AWS Lambda. Correct. As I told you, you can also connect to API gateway, right? And from API gateway to connect to a Lambda, and then Lambda can connect to some other services also. So that seamless workflow you need to create based on your requirement. You can identify where you need to use it. So Quarkus is one of the framework which is built on top of Java, which is used for developing a cloud native applications, right? You can also develop Lambda functions using a Java, using that Spring Boot also, using the Quarkus also, right? So for cloud native applications, here we can also use that AWS Lambda. As I told you, we can also use Node.js, we can use a C Sharp, maybe we can use other scripting language also to create a AWS Lambda function. So this is one of that diagram where you can see Amazon API gateway is connecting to AWS Lambda, and Lambda is connecting to Amazon DynamoDB. So Lambda can also connect to some other services also, maybe any other services, putting a message to a queue also, right? So there is a lot of work. So you can treat as an independent function as a service which is running without managing the infrastructure, right? Now let's come and discuss about the microservice architecture. Microservice architecture, everybody knows about it. Now here we are talking about microservices modernization and microservices migration also. So why we are talking about microservices modernization and migration? Many such legacy applications are getting migrated into microservice architecture on the cloud, correct? So there are multiple ways you can deploy and set up the application microservices on AWS or maybe any other cloud application. Or so in when we are talking about cloud, maybe Azure, AWS, GCP, right? So microservices principles, it is saying that microservices is supporting for domain driven design. Also, we can look for 12-factor design for microservices. And when we are talking about domain-driven design, it is built around serving a single business function, right? So for single domain object, you can perform a multiple operations, right? Let's say if you wanted to create a microservices for customer operations, so you can create a microservice for customer operation, all other CRUD operations like that. For reporting, for transaction like this. So multiple microservices we will see. Here you can see that catalog service, shopping cart service, discount ordering service, payment service, customer service, right? Vendor service, like that, multiple services you can use it for different business function. API gateway, which is connecting to microservices, it is one of that microservices pattern. From client tab, maybe it is web or mobile app, you will connect to API gateway. From that, you will connect to microservices, and microservices can connect to independent database, right? Or you can connect to a single database also. So this is the way this microservices you can design for e-commerce application, right? You can also see and visit to our YouTube channel. There is a complete video which we have created to design microservices on e-commerce application. What are the tools you need it for UI applications? What are the tools you need to use it for backend applications, database configurations, database, you can say design, deployments, how you can deploy the microservices using what are the different tools are required, how you can set up a CI/CD pipeline. So the complete architectural concept then diagram for your deployment for you can say system design, you can find it out on our channel, correct? Now Let's talk about common design pattern. So common design pattern is API gateway, circuit breaker, Saga patterns, right? Routing, uh, build and deployment patterns like this. So there are a different microservices patterns which is helping it to you for creating a design, creating, you can say, microservices, deployment of a microservices, communication between the microservices, right? Which is all giving you much more facility for reliability and fault tolerance also. So circuit breaker and API gateway, which is coming under that routing patterns, helping it to you for fault tolerance as well, right? Now, this is we already discussed, right? So how you can connect from web to a mobile. Now, can you compare your serverless with the microservices, right? Idea is you can also create a microservices using a AWS Lambda as well, right? So scalability and flexibility, right? Microservices provide a fine-grained scalability per service, while serverless automatically scale function based on the demand, both offering high flexibility in resource uses, right? So in that scenario, you can use fine-grained scalability for per service, right? And serverless concept, which is a lot of facilities provided from the cloud, right? Automatically you can scale the functions, right? Microservices requires a container orchestration, nothing but you will create a container using a Docker, and then you will deploy these containers on Kubernetes. So that is we called as a container orchestration for deployment, right? Serverless uh, abstract this underlying infrastructure. You don't need to work for all containerizations as well as for orchestration. These things you don't need to scratch your head, correct, when we are talking about serverless concept. Cost implications: microservices offering a more complex to manage can lead to a predictable cost. So serverless, as I already discussed with you, it is a pay per use. How many requests you are using, that consumption and resource utilization which generate and uh, basically give the cost to you, right? In microservices, it is little bit complex when you are managing it, communications, deployment, monitoring, because it is a lot of services are running parallelly, and you are managing it from your own uh, in containers or in orchestration tool like a Kubernetes. So that is also a overhead, correct? So cost implications is also it is there, and design is also, you can say, creating some issues, right? But on top of it, in serverless, debugging will be a little difficult as compared to microservices, because microservices architecture, which is you have created and deployed from your own, right? So you will have a much more direct control on these services. You can easily check the logs, debug it, and easily find it out the issues, correct? But in AWS Lambda, there are some limitations which we already discussed earlier in this session here, correct? So you need to understand where you will go with the serverless. So here we are not talking about only here just AWS Lambda. There is also a service called as the AWS AppSync, which is a ready-made services for GraphQL APIs. So rather than to create your own GraphQL APIs, you can also use AWS AppSync, and you can expose your APIs and based on your domain objects or based on your requirement, correct? So that is also serverless computing. So this is all about what we can call serverless concept, AWS Lambda, cloud computing. So, and the comparison between AWS Lambda and microservice architecture, correct? You guys can let me know exactly which particular details you really correlate and you identify that it is really helpful to you, correct? Where you will use AWS Lambda, where you will use microservices, which particular language or technology you will use it to develop that microservices, and which is your preferable language to create AWS Lambda also, right? So I will waiting for your response. You can also give much more comment for system design and understanding much more concept for AWS and different AWS services. Thank you.